Have you ever looked at the specs on a graphics card box and just kind of glazed over? All those numbers about gigabytes and bandwidth? Well, today we're going to pull back the curtain on your GPU's memory system. We're going to find out why it's the secret hero, or sometimes the villain, behind pretty much everything you do.
So, picture this. You've spent some serious cash on a top-of-the-line GPU. I mean, this thing is a beast, right? It's got more power than a supercomputer from just a few years ago. So why, when you crank up those 4K textures or start training a new AI model, does it sometimes just choke? It's super frustrating, but the answer isn't in the processor. Nope. It's in the system that's supposed to be feeding it.
Here's the real problem, and it's kind of crazy when you think about it. You have thousands of super powerful processing cores that are just sitting there, waiting. They are literally starving for work. It's like having the world's most efficient factory workers, but the conveyor belt bringing them parts is completely empty. All that raw power means nothing if they can't get the data they need, right when they need it. And that is the bottleneck we're here to understand.
Okay, so how do we fix this whole data starvation thing? Well, we need to look at the GPU's memory system. This is way more than just a storage locker. Think of it as a super high-speed, precision-engineered delivery service designed for one job and one job only, to keep those thousands of hungry cores fed and busy. First things first, let's get the big picture. Everything the GPU needs to actually work on. We're talking game textures, 3D models, massive AI datasets, the whole shebang. It all gets loaded into something called global memory. You can just think of it as the main warehouse for the entire graphics card. So if global memory is the concept of the warehouse, what's the actual building made of? Well, that's VRAM, or video RAM. These are the actual physical memory chips you can see on the circuit board. It's the hardware that makes the whole thing possible.
And that brings us to maybe the most critical number of all, bandwidth. If VRAM is the warehouse, bandwidth is the speed of that conveyor belt connecting it to the factory floor. It's how fast data can move from storage to the cores. You could have a warehouse the size of a city, but if you've got a slow, creaky conveyor belt, your workers are always going to be waiting around. Now here's where it gets really interesting. Not all memory is built the same. In the world of GPUs, there are two major competing technologies, and they have completely different philosophies on how to solve this data feeding problem. Let's meet the two titans, GDDR and HBM.
It really boils down to two different strategies. GDDR bets everything on raw speed, moving data incredibly fast down a relatively small number of lanes. Think of it like a Formula One car. HBM, on the other hand, is all about parallelism. It moves data down a huge number of lanes all at once, but at a slower clock speed. It's more like a whole fleet of giant cargo trucks. So it's a classic battle, pure speed versus massive width.
Okay, let's talk about GDDR, the drag racer. This is what you'll find in pretty much every consumer graphics card you can buy. The memory chips are laid out flat on the board surrounding the GPU, and its entire design philosophy, from the older GDDR5 to the newest GDDR6X, is all about one thing: hitting ridiculously high clock speeds to jam data through its narrower data path as fast as physically possible. And then you have the other approach, HBM, or high bandwidth memory. This is the cargo train, or maybe a 16-lane superhighway. Instead of lying flat, HBM chips are stacked vertically, one on top of the other, into a dense little cube that sits right next to the GPU. This super close proximity allows for an incredibly wide data path. It runs at a lower speed, sure, but it moves a truly immense amount of data all at the same time. So, we've got these two different approaches, the drag racer and the cargo train. But how do we actually measure their performance? What are the key numbers on the box that tell us how good they are at feeding that beast of a GPU? Let's break down the scorecard.
The big number everyone cares about is total bandwidth, and the math is actually pretty simple. You just take the width of the data bus, that's how many lanes you have on your highway, and you multiply it by the clock speed, which is like the speed limit on that highway. Put them together, and that gives you your theoretical max data speed in gigabytes per second.
But wait, speed isn't everything. The other massive piece of the puzzle is capacity, the total size of your warehouse, measured in gigabytes. This is the number you usually see advertised the most. Here's why it matters. If your game or application needs more data than your VRAM can actually hold, the system has to go all the way out to your computer's main system RAM to get it, and that is dramatically slower. It's what causes that horrible game-breaking stuttering that just brings your performance to a crawl. Okay, so that's a lot of tech talk, I get it. Terms, trade-offs, tech. But why should you actually care? Well,
because this stuff directly impacts every single thing you do with your GPU, whether you're gaming, creating, or doing anything in between. Let's connect the dots.
For you gamers out there, this is everything. Playing at 4K with all the settings maxed out means loading absolutely gigantic high-resolution textures. If your VRAM capacity is too small, you'll see textures pop in late, or worse, the game will stutter and lag as it tries to pull data from slower storage. And high bandwidth? That's what you need for that constant, smooth stream of data to get those buttery smooth high frame rates we all crave. Now, in the world of AI and machine learning, the name of the game is just raw data throughput. You need to feed massive, massive data sets to the processing cores as fast as humanly possible. This is where bandwidth is king, and it's exactly why HBM memory is basically a requirement for any serious AI hardware. More bandwidth directly means less time waiting, which means faster model training and quicker results. And for all you creators, a powerful memory system is just non-negotiable. If you're editing 8K video, you need a huge amount of VRAM capacity just to hold all that frame data. And high bandwidth is what lets you scrub through your timeline smoothly, with a bunch of effects and color grades applied in real time, without dropping frames and totally killing your creative flow. So if HBM is so incredible, you're probably asking, why don't we see it everywhere? And well, like with everything in engineering, it all comes down to some really difficult trade-offs. There's just no free lunch, and there's no single best solution. There's only the right solution for a specific budget and a specific job. This table pretty much lays out the whole dilemma. GDDR is the workhorse. It's cheaper, it's simpler to manufacture, and that makes it the perfect choice for consumer cards where price is a huge deal. HBM, on the other hand, is the thoroughbred racehorse. It offers mind-blowing bandwidth and a smaller footprint, but it's super complex and expensive to make. That's why you really only see it in those top-tier professional cards where performance is worth any price. And, no matter which tech you pick, there are some fundamental limits you just can't get around. For one, even though this memory is fast, it's still far away in computing terms. It can take hundreds of clock cycles just to grab one piece of data. Pushing data this fast also creates a ton of heat, which can slow things down if your cooling isn't up to snuff. And maybe most important of all, VRAM is not upgradable. What you buy is what you're stuck with for the life of the card. If you take away one thing from all this, let it be this. You can have the fastest, most powerful processor in the world, but if its memory system can't keep up, all that power is completely and totally wasted. Your entire system will only ever be as fast as its slowest link, and very often, that link is the memory. So, as we wrap up, I want to leave you with a question. Your computer, your console, your entire workflow, it's all a chain of different parts working together. Now that you understand just how critical GPU memory is, take a fresh look at your own setup. Where's the weak link? Which part do you think is holding you back? Now you know where to start looking. Thanks for tuning in.